Hey, good morning, everyone. Today I'm going to talk about chapter 3, new chapters. It's about the vector and the motion in two-dimensional uh, kinematics. But you will see this is basically two-dimensional kinematics. It's simply the same as one-dimensional kinematics. So if you assume you understand chapter 2, you will have no problem. So let's start with the vector first. I believe everybody understand the vector, right? What is a vector? Vector is has a two quantities, which is called magnitude and it's a direction. And then vector is extremely important in physics because a lot of quantities, one quantity that two quantities actually three, displacement, velocity and acceleration and even force, they are all vectors. So, knowing vector is about, knowing a lot about physics as well. So make sure you understand, what the vector is, okay? So for example, C vector is the net displacement because it describes the net result of the hikers having, first the displacement A, then displacement B. For example, here, okay, you start from position P, and then let's assume, vector A is 4 mile to the east. And then let's say vector B is what? 3 mile to the north. Again, as I said here, vector A, 4 miles. So 4, this number corresponds to magnitude. And then to the east is about the direction. And then V vector, same. 3 mile magnitude, north direction, right? So assuming sure vector always consists of about two parts, magnitude and the direction. And then displacement, as I said, is a vector. Because you remember why. Displacement is always comes with the two parts, right? In one dimensional space, of course, you need five meter per meter or minus 5 meter, right? So that means there five is magnitude plus minus means it's the direction. So in one dimensional space, it's either to the right or to the left. Right, positive, left, negative, right? And then now the question is how you add two vectors. So a vector, it's for example, we already know we start from here. A vector, you travel 4 mile to east. And then B vector, you travel 3 mile to north. So then C vector, which is a sum of A plus B, is simply you connect the line that you start, your starting point is P, right? End point is your S. So this vector is your C vector. And of course, you can also have a find the C vector using by changing the order like here. You can also say C vector is what? B vector plus A vector. Think about why. If you go B vector first, what does that mean? You travel to the north 3 mile first, and then you move to the east 4 mile. So your final position here is anyway same location. So again, if you connect your initial position and your final position, you connect it. This is your C vector. Of course, the C vector has its own magnitude and the length. We'll talk about it. Magnitude and the direction, right? So then simply how to add two vectors. So this is called tip to tail rule of a vector addition. And then another one is a parallelogram rule, but I think tip to tail rule should be enough. So the basically it's the same as what we did here. You draw the first vector, so tip to tail rule, place the tail, which is the second vector, tail of a second vector at the tip of first vector. And then and you connect your starting point to the end point. This is your sum of two vectors. So now we have a question. Given vectors P and Q, what is the P plus Q? Again, this rule is same. You draw the P vectors, which is already drawn, and then you move Q vectors. In other words, you draw the tail of Q vectors at the head or tip of P vectors. So this is now your Q vectors. And then if you connect, this is your start, this is your end, right? This is your P plus Q vector. So the answer is A. So one very confusing concept of a vector is here. So assuming you, so in general, let me briefly introduce the vector. So assuming we have a vector, and again, vector is always have two quantities. As I said, the magnitude, which is the length of the line, or length, and the second one is about the angle. So angle is in general, you describe this angle in angle from the horizontal positive x-axis. So you measure the angle from here. So assuming your a vector is this, for example, and then let's say the magnitude is 2, the length of the line is 2, then you measure the angle from here, which is 90 degrees. So in other words, your a vector for this case is what? 2, 90 degrees. That's a vector. Okay. So one confusing part of a vector is about here. So let's assume we have again our a vector, so let's say our new a vector is 2, 45 degrees. So that means our new a vector is this. Length here is 2, and then angle 45. So we measure angle from here, x-axis. So this is a 45 degrees. So then you can draw a vector. So the next question is, let's assume we have another vector, which is called b vector, right here at different location. A vector, tail is origin, tip is here, but b vector has the tail here, so it's a tab is here, tip is here. Of course, it's the same magnitude. The angle from the horizontal line is 45 degrees, so this is a 2 as well. So it's the shape is very similar with that, exactly the same as the a vectors. So my question here is the a vector are the same as the v vector? Yes or no? So the answer is a yes. So even though their location, a v vector has what? Different location, right? But they are the same because why? Their magnitude, how you describe a vector in terms of a magnitude and an angle, right? From the horizontal line. So your a vector magnitude 2, b vector your magnitude is 2, the length, and then the angle from the horizontal line for a vector is 45 degrees, and the b vector is also 45 degrees, right? Assuming we have this imaginary horizontal line, the angle is 45. So as long as they have the same magnitude and the same angle from the horizontal line, we assume these two vectors are the same. And then this is why, if we come back this question, we have a p vectors here, right? And then q vectors location is here. So you cannot, right, directly add these two vectors as we did here, right? But as I said, as long as you didn't change the length of the vector v, q, and then as long as you didn't change the angle from the horizontal, for this case, q vector is to the left, right, along x-axis. So as long as you didn't change the angle of a q vector, so in other words, q, you make a q something like that, or q something like that, no. But as long as you have the same q length to the same angle, with the same angle, then q same. You can move this q to here. Same length, same angle from the horizontal line. For this case, it's a 180 degrees from the positive x-axis, right? So this Q also have a same length, and then angle from the positive x-axis is a 180 degrees. So you can move your Q vectors. So then now answer is a, right? So then multiplication via scalar. Sometimes you see, vector A, assuming this times the length of this, length is let's say A without the vector symbol, and then angle is a theta. So then now you can say A vector is what? Magnitude A, angle theta. But sometimes you will see another vector. This is similar with A vector, but slightly different with this coefficient C in front of A vector. So then this means that you increase or you stretch the length of a vector A by the factor of a C. So for example, let's say C is 2, then B vector has a 2 times longer than A vector. But you should not change the angle. So in other words, the B vector is what? Because you increase the length 2 times, so it's a 2 times A, and then angle is still theta, right? So whenever you see coefficient in front of a vector, you simply stretch the length of the vector only, not the angle part. A vector cannot have a negative magnitude, right? If you multiply a vector by a negative number, so that means you reserve its direction. So for example, here we have an A vector. B vector is 2A vector. So now the angle, the length is 2 times greater, but you still have the same angle, theta, from the horizontal, theta. But if you have a minus 3A vector, so that means you have to switch the direction to the opposite. So that's what minus actually indicate. And then 3 here indicate the length is again 3 times greater. Right? And then what is the A plus B vector? This question. Again, you see this question is the same, right? You can either do A plus B, or this is same as a B vector plus a vector. So that means you move B vector this way, right? So this is the same as a B vector, right? Same magnitude, same angle from the horizontal, same angle from the horizontal x-axis, right? So your vector A plus B is connecting your starting point to the end point. So this is your vector sum. So the answer is C. Or you can also do, the other way, opposite way. You can add, as I said here, you can add B first. So then B first, then you have to draw A vector, which is the same as this vector. Then you will see answer the same. Right? So how you subtract your vector? So let's assume you have a vector minus B vector. But this is nothing but what? A vector plus minus B vector. But now we know what is a minus B vector. Minus B vector is what? Simply, same magnitude of B vector in opposite direction, right? So you just draw minus B vector and add with the A vector. So in other words, assuming we have a vector, B vector, right? We don't want to add these two. Instead, we want to add A vector plus minus B vector, right? So you have to draw the minus B vector, which is right? So then, in order to add these two vectors, again, you draw A vector first, and you draw minus B vector, and then connect starting to the end. So this is going to be your A minus B vector. Again, you can also switch the order, right? You can do minus B vector first, which is minus B vector first, and A vector later, right? And then you see this is A minus B vector as well. The answer, the order doesn't matter. So what is a P minus Q vector? So again, P minus Q vector is what? P vector plus minus Q vector. So you have to draw minus Q vector first. So because this is a Q vector, minus Q vector is what? The same magnitude, opposite direction. So this is gonna be your minus Q vector. Then you gotta add P and minus Q vector. So draw P first and then draw minus Q vectors. So this is minus Q vectors. So they connect, start, and end. So this is a P minus Q vector. So your answer is a D. And then how about 2A minus B vectors? So then 2A vector, how you calculate the 2A vectors? Again, 2 times longer, same direction. So your 2A vector is what? 2 times longer. So this is your 2A vector. And again, what is your minus B vector? Again, this is your B vector. Your minus B vector is something like this, right? And then again, you want to add this 2A vector plus minus B vector, right? So you draw the 2A vector first. So if I redraw this 2A vector, it's something like this. This is A vector, right? 2 times longer. And the minus B vector is what? This is minus B vector. This is a 2A vector. So the answer 2A plus minus B vector is simply this vector. So the answer is A. Right? So today's lecture is relatively short, but I make this lecture very short because of the concept here, how to add the two vectors, how you subtract vectors. What is the physical meaning or coefficient of a vector is extremely, extremely, extremely important. We got to use these rules and then this method over and over, even for the next method as well. So make sure you go over all slides very carefully and let me know if you have any question.